Hello everyone, and welcome to your video on extraneous roots. So I think the best way to learn about extraneous roots is to do a problem. So here we have the square root of x equals x minus 2. So this is a nice easy problem for us to work on. So the first thing that we would do here is to try to get rid of this radical sign. And so we're going to do that by squaring both sides of the equation. So that's going to give us x equals, and then I'm just going to write this out properly so that then I can FOIL it nicely. So I get x equals x squared minus 2x minus 2x plus 4. I just FOILed that out. And now I'm going to combine like terms. So I get x equals x squared minus 4x plus 4. I'm going to subtract the x from this side so that I have a 0 set equal to my quadratic equation. So x squared minus 5x plus 4. Okay, we haven't done anything new here. We've just kind of pushed through this problem. So 0 is going to equal this equation factored out. So I need to think of two numbers that multiply together to make positive 4, but add together to make negative 5. And the answer there is going to be negative 4 and negative 1, because negative 4 times negative 1 gives us positive 4, and negative 4 plus negative 1 gives us negative 5. All right, so now I say, all right, x minus 4 equals 0, or x minus 1 equals 0. So here, x equals 4, or we have x equals 1. All right, so far we haven't done anything new. Here's what happens now though. We have to check that these are valid answers. There's no guarantee that they are valid. And so we need to look and see if they truly work out. So what I'm going to do is I am first going to test my x equals 4 answer. That's the first one that I'm going to test. So let's see what we get. So I'm just going to plug in a 4 every time I see an x. So the square root of 4 equals 4 minus 2. And what we're trying to figure out is that true? Well, what is the principal square root of 4? That would be a 2. And what is 4 minus 2? That's a 2. So hey, that checks, and this is a valid answer to our original problem. Let's take a look at the second option, which is x equals 1. So here I would put in a 1 every time I see an x. So the square root of 1 equals 1 minus 2, and we are checking to see if that is true. Well, the principal square root of 1 is just plain old 1. And 1 minus 2 gives us negative 1. And so we can see that 1 does not equal negative 1. So this is a wrong solution. In other words, it is an extraneous root, which is just a fancy term that means wrong answer. So you solved it correctly to get to x equals 1, but when you reverse the process and put the 1 back into the equation, it doesn't work out. Now you might be asking yourself, why do we get extraneous roots? And the answer is because we're doing the squaring and the square rooting. That stuff messes with the algebra, because you can wind up with positive and negative answers and things get a little wonky. So whenever you have squares or square roots, you're going to have to check for extraneous roots. There is no way to avoid it. There is no way that you can just look at these two numbers and tell something special about them to know which ones work and which don't. You have to do the check. If you were taking a test and I asked you what the answer to this problem was, and you told me x equals 4 or x equals -1, you would be wrong and you would get the question wrong, because the only valid answer to this problem is x equals 4. All right, so that is the deal with extraneous roots. I know it makes you unhappy because you're going to have to do all these checks, but life is hard. That is the way math is. So accept it, buck up, and do a good job.